our last type of proof we're going to talk about is the one that is the most obviously a proof technique. The other things were just basic logic reasoning that you can probably have guessed. This, I would highly doubt you would guess this. This is called mathematical induction. It's a way of proving something is true for any natural number. If you look, the conclusion here is that for all n, p of n. And the way that we do this is if you can show that p of 0 is true, and that for any n, p of n implies p of n plus 1, then you prove this. How on earth is that true? So, what we prove is p of 0, and I always know, no matter what number I plug in, that I can imply the next thing. So if p of 0 implies p of 1, then I know p of 1 is true by using modus ponens, our direct proof method. After that, I know p of 1 implies p of 2. So therefore, we have p of 2. And then p of 2 would imply p of 3. And you could keep chaining these implications together over and over and over and over again, continually applying modus ponens, until eventually you get to the number you cared about. So if you wanted to know how you would prove that it would be true for 4,338, then you would do this 4,338 times until eventually you get that 4,337 implies 4,338. This is the idea of continually chaining modus ponens together. This is a surprisingly useful technique, and we'll see it used for a couple of things in this class. We're going to use it here for some basic divisibility stuff like we did before, but it can also be used for things later in the class like proving that a recurrence relation for a recursive function is true, or proving summation formulas are true. So we're going to use this in a variety of ways, and it is surprisingly applicable for being this sort of seemingly symbolically dense thing. We'll see how to use this in our first example. For now, know that you need to prove the base case. What we're going to call p of 0 is the base case, and then this is sometimes called the inductive step. And we'll see this worked out in sufficient detail, hopefully, in the next problem.